Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on curve sketching. So I'll be giving you a polynomial that you need to turn into a graph. So follow these 4 steps. Firstly, look at the orientation, and by that I mean look at what happens as x gets larger, more and more positive, and more negative. Secondly, find the y-intercept by letting x equal 0. That's really easy. The x-intercept by letting y equal 0 takes a bit of work, and the stationary points also take a bit of work. Sketching by hand is not easy. It takes a long time, but following these 4 steps, we should be able to do it without too much hair pulling. All right, let's look at an example. I'm going to graph this function here by finding each of these 4 things. So firstly, let's look at its orientation. So what happens as x gets larger and larger, this function just gets larger and larger. So y is just going to go larger and larger. Of course, remember, y and fx are exactly the same thing. So as x gets more negative, y is going to get more negative. So this function here is a cubic. Its orientation, it's always like this. That's if the leading coefficient a is positive, and it's the other way. It looks like that if a is negative. So here a is positive, it's going to look like this. As x gets larger and larger, y shoots off to infinity, gets larger. As x gets more and more negative, y gets more and more negative, shoots off to negative infinity. So the graph is going to have this basic shape for this one here. So that's 4 cubics. Okay, so let's find the y-intercept. That's really easy. If x is equal to 0, y is just equal to 12. So, thirdly, I'm going to calculate the x-intercept. So this isn't easy. I need to solve the equation x cubed minus 13x plus 12 is equal to 0. So remember, what I need to do is come up with one such solution and then use polynomial long division. So in this one, it's easy to come up with the first solution. It's easy to see that f of 1 is equal to 0. Because 1 plus 12 minus 13 equals 0. So this means that x minus 1 is a factor, so I'm going to use polynomial long division here. So there's no x squared term, but remember I need to write it when using polynomial long division. So using polynomial long division, hopefully you remember it, I go x into x cubed, leading term into leading term, that's x squared. Multiplying x squared by x minus 1, I get x cubed minus x squared. And remember, I subtract to find out the remainder. So 0x squared minus x squared gives me x squared. When I get a remainder, divide it by leading term. X squared divided by x is just positive x. So then I'm going to bring down this negative 13x. Whenever I get a term up here, I multiply it by this. So I go x times x, and then x times negative 1. So again, I'm going to subtract to find the remainder, and I get minus 12x. Divide the remainder by the leading term, I get this. So I can bring down the positive 12 times minus 12 by x minus 1. I also get minus 12x plus 12. So that means the remainder of this is 0. So I've found that fx is equal to x minus 1 multiplied by x squared plus x minus 12. So I can now factorize this quadratic really easy. I get x minus 1 and then x plus 4, x minus 3. So this is what I found so far. I found the orientation of this is like that. I found the y-intercept is equal to 12, and the x-intercepts are the solutions to this equation here. So the x-intercepts are 1, minus 4, and 3. So this is a lot of work. I've done the first 3 steps. Now I need to do the 4th step. So I'm going to get rid of all this working. Please pause and copy down if you need. So this is what I know so far. I know it's going to have y-intercept of 12 and I know it's going to have x-intercepts of 1, 3, and -4. Without the stationary points, though, I don't know if it's going to go here, and then come down, then go up. Okay, it could go like that. It could also go through here, and have a stationary point down here, go up like that. I just don't know what it's going to look like. And that's why it's so important that I calculate the stationary points. So to calculate the stationary points, what I need to do is differentiate the function. So if this is f of x, f dash x, the derivative, is just going to be 3x squared minus 13. So the stationary points occur when this is equal to 0. So what I have here, I can solve it like this. 3x squared is equal to 13. X squared is 13 on 3. So x will be plus or minus the square root of 13 on 3. So the answer I get here for the two stationary points is about plus or minus 2.08. So there's a stationary point when x is 2.08 and a stationary point when x is about minus 2.08. So substituting this value into the original equation, I get y is minus 6.04. Substituting this value into the original equation, I get 30.04. These are the two stationary points. So now I'm going to determine whether each point is a maximum or a minimum. So I've picked the two stationary points here, and each of them has a point just less than it, just more than it, so we can determine whether the gradient is positive or negative beforehand. So if I substitute x equals minus 3 into the gradient here, I get positive. It's 0 at these 2 points. If I substitute x equals 0, the gradient is negative. If I substitute x is positive 3 into here, the gradient is again positive. So that means the gradient's increasing, then it's stationary, then decreasing, stationary, increasing. So I have found that this point here is a minimum, and the other point is a maximum. I now have everything I need to graph this function. So this is what I have. It will go through the x-intercepts at -4, 1, and 3, y-intercept of 12. So it's got a stationary point of minus 2.0830, so it's going to be up around here. Can just estimate that point. And then 2.08 minus 6.04 down here is a minimum turning point. So just joining all of these up, it goes like this, because remember, as x gets more negative, y goes to negative infinity. So then it will hit its maximum turning point, stop and turn around. It's going to come and hit the y-intercept, then the x-intercept, and then minimum turning point around here. And then it's going to go up and shoot off to infinity. And that's what the graph looks like. Sorry for the poor sketch. All right, now I'm going to do another type of example, but try and go through it quickly. So please pause and copy this down if you need. So let's go about graphing this function here, which is in factorized form. So firstly, we'll look at the orientation. So as x gets larger, this is always going to be positive. This is always going to be positive. So as x gets larger, y is going to get larger. But as x approaches negative infinity, it becomes more and more negative, y is going to approach positive infinity. If you're not sure why this is, to see what happens as x approaches infinity, just substitute a really large number for x, you'll get a really large number for y. Substitute a really large negative number for x into this, and you'll get a really large positive number for y. So this is going to go to something like this, might have a few turning points, it'll look something like that. That's what its orientation will look like. So, to find the y-intercept, just let x equal 0. So I get x plus 2 squared times x minus 3 squared, and that gives us 36. So that will be the y-intercept. So finding the x-intercepts is easy here because I'm given this in factorized form. So if fx is equal to 0, x will just be minus 2 and positive 3. So the thing is, because there's a 2 here, x equals minus 2 and x equals 3 are double roots. What that means is we're also going to see that these will be turning points or stationary points. So calculating the stationary points is hard for this. We don't know how to differentiate functions like this. So what we're going to need to do is expand this. So x plus 2 squared gives you x squared plus 4x plus 4, and x minus 3 squared gives you x squared minus 6x plus 9. This is just another way to write f of x. So now I'm going to expand this by timesing everything in the first bracket by everything in the second bracket. So timesing everything in the second bracket by x squared, I have this. And then I'm going to do the same to the others. I'm going to times everything in the second bracket by 4x. And then I'm going to times everything in the second bracket by 4. So I got 4x squared minus 24x plus 36. So when I collect like terms, I get fx is equal to x to the power of 4 minus 2x cubed minus 11x squared plus 12x plus 36. So to find the stationary points, I need to differentiate this. So I get 4x cubed minus 6x squared minus 22x plus 12. So to find where this is equal to 0, I do need to factorize it, which looks like it would take a lot of work. But because I have a double root at minus 2 and 3, I know that they are going to give us factors of this. So x plus 2 will be a factor of this. X minus 3 will also be a factor. So either way you do it, you end up with something that looks like this. So you can start with x plus 2 or x minus 3 and again use long division. But I won't go through that here so I can keep the video nice and short, but please ask me if you're unsure. So if f dash x is equal to 0, the solutions are x equals minus 2. If 2x minus 1 equals 0, x equals positive a half, or x equals 3. They are the 3 stationary points. So if we apply the first derivative test, it turns out x equals minus 2 and x equals 3 are both minimum turning points, and x equals a half is a maximum stationary point. We now have enough information to graph. So what will this graph look like? Well, what we know is that minus 2 is both an x-intercept and a minimum turning point. So it's going to look like this. We know the same for x equals 3. It's an intercept and a turning point. So because it's a minimum turning point, it's going to look like that. So we know that this function's going to have a y-intercept of 36. Now the other stationary point, the other turning point is x equals a half. Now when x equals a half, if I substitute it into here, I get y equals 39.0625. So that turning point is going to be up around here. Now we know that it's going to look something like this. It's going to go off to infinity in both directions. So the total graph is going to look like this. Stops, turns around. It's going to go through the y-intercept, turning point here, come down, and go like that. This is what the graph looks like. So I know it's not easy. It takes a long time. It took me a long time in this video. Just make sure you concentrate and go through these 4 steps. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.